So for probability this week, we're going to talk about the topics listed here. I've mentioned them in the overview. There's a little bit of terminology to make sure we understand how we are discussing these things. Independent and mutually exclusive events. There are basic rules of probability. This would be the addition rule and the multiplication rule. And then the contingency tables and Venn and tree diagrams. So that's kind of where we're headed. Hopefully we will get there. Starting with terminology. So probability is really associated with how certain we are that certain outcomes will happen. So to discuss this, we need to make sure that we understand some terms and how they're used in probability. An experiment, we understand what a scientific experiment is, but an experiment in probability is what is actually going to happen under controlled circumstances. And the experiment is said to be a chance experiment if the result is not predetermined. And the result of that experiment is our outcome. The sample space of an experiment is all possible outcomes. So we can list the whole sample space if it is something that is defined, like a data set that we are looking to see if it's going to be the number 1, 2, or 3. We can list those. We also can create a tree diagram to show those possibilities, those different kinds of outcomes, or we can create a Venn diagram, whichever one fits our needs best. There's some at the bottom of this slide that talks about using the capital letter S to represent all sample space, and that will become apparent, I think, as we move through some of these examples. An event is actually what we're looking for. Let's say we're flipping a coin, and what we're looking for is to see if it is a heads. That is the event that we are looking for. So we have to define what we want that event to be so that we can see if we have a positive outcome or a negative outcome or a not positive outcome. Probabilities are always just between 0 and 1. 0 probability means that event can never happen. And the probability of 1 means that that always happens. So anywhere in between, and some people say there's no numbers in between 0 and 1. Yes, there are. There's lots and lots of numbers in between 0 and 1, and we have that probability. A 0.5, half and half, 50-50 means that it's equally likely for the event to occur or not occur, such as in flipping one coin, getting a head or a tail, equally likely. So when an event is equally likely, there's an example that's written there with the flipping a coin, with rolling one of the number on the face of a die, things like that. We can calculate it differently because they're all equally likely. So to calculate the probability of an event A, whatever it is we're after, let's say we want to roll a 2 or we want to flip a coin and get a head, that is the event. Remember that terminology. When all outcomes are equally likely, we count the number of outcomes possible. The number of possibilities, I think, is the way it is done sometimes in classes, and the total number that outcome happens in that sample space, and we get our probability. For example, okay, there are 6 sides to a dice, and if I want to roll a 2, that is just one of my 6 choices, so 1 over 6. All of those words there, that's what that means. The law of large numbers, that's hard to say, just means that we have in our minds what that probability is. Let's go back to rolling a 2 out of that die. I have 1 in 6 chance of rolling a 2. Well, does that mean that if I roll it 6 times, I'm going to get a 2? It does not. It means that that is the probability. And the law of large numbers means if I were to perform that experiment millions of times, large number of times, then that experiment will get closer to the theoretical probability. And in some textbooks, it talks about theoretical probability and experimental probability, which is what actually happens. And as we do it multiple times, large numbers means that we are going to approach that. If I flip a coin, does it mean that out of 10 times I'm going to get 5 heads and 5 tails? You know that it doesn't because you've probably tried that, right? But it means if I flip it 1,000,000 times, I'm going to get pretty close to half and half. So that's what the law of large numbers is all about, approaching that theoretical probability with our experimental probability. The terms or and might mean something different to you, so make sure that you understand those definitions. If event A or B can occur, then it means I have quite a large pool of possibles, right? I have everything that can happen with A and everything that can happen with B. A or B means all of that, inclusive. And there's an example listed there. And means I'm going to shrink that pool because it has to not only meet the criteria for A, but it also has to meet the criteria for B. So I am having a smaller pool of numbers for that. It has to have both conditions met. So sometimes we think of and as being a larger pool and or being a smaller pool. It is the opposite way in probability. So hopefully those examples there will help you understand that. The complement just means not. So the complement of event A is denoted in this textbook as A prime with that little prime after it. And it just means everything that is not A. Another, I wrote down at the bottom, the former book that we had and many other textbooks use this little tilde in front of the A, and that means we just read that as not A instead of the A prime. Both of them mean complement of A, which is another way of saying everything that is not A. When I have the complement and the event together, that is going to result in 0 because it's all of my possibilities then. I have everything that's A and everything that's not A, that's going to include everything. So that probability is always 1. Conditional probability, I'm going off the screen here, sorry. I'll move myself over a bit. The conditional probability of A given B, that means I have two things happening. What's the probability that A is going to happen if B has already happened? It's written in this way with that line in between the A and the B right there. And it's the probability that event A will occur given that B has already occurred. It is a conditional probability, and it reduces that sample space again because we've already done B. So whatever results we get from B, that's what I'm drawing on for the event A. And so therefore, the calculation is from this formula that you can see there. Of course, the probability of B has to be greater than 0 and not equal to 0, or this equation does not work because we cannot divide by 0. I hope this becomes clear. And lots of words right here, right? But this is just saying the probability of A and B happening. So I take both of those together. I'm multiplying the probability of A and the probability of B, and I'm dividing by the probability of B. So this means that what's the probability after B has occurred? So keep that in mind. I think there is an example in the next group of slides. Oh, maybe it's right here. Huh. I'm smarter than I thought, right? Let me move my face up. Well, I don't know where. We'll just plop right here for now. So if we're going to toss this coin again, right? I know one fair 6-sided dice, the sample space is going to be 1 through 6. So if A is going to be a 2 or a 3, and B is going to be an even number, a 2, 4, or 6, if we are calculating the probability then of A that happening after B has happened, we're going to count the number of outcomes. It's going to be either a 2 or a 3 for the A, and we're going to use, instead of our whole sample space, we're just going to use the sample space of B, because what we're saying over here is the probability of A happening after B has happened. So we're going to have B be our sample pool, and then we're going to see what's the probability of A happening. Well, if you look at it, there's only one that is in both of those, right? So it is going to be that one, and there's only 3 possibilities, so it will be 1/3. You can see how that fits in with this more complex formula that uses the fractions, but really I think this shortcut is a good way. We're dividing by our sample size, in this case, is the event B has already happened. So we have one possibility out of A over the 3. If we're going to do it this way, we're going to say 2 out of 6. There's 2 possibilities there out of all 6 dice. And so we have 2 out of 6 divided by our 3 out of 6. And so we have to do the little invert and multiply, and we get 1 out of 3. Whichever is easier for you to understand. I think that first way is a little more intuitive. But formulas are always helpful when problems get a little bit difficult. So here's a little bit of understanding terminology. And in the next slide, there are actually the answers. So here we're talking about the sample space of all the whole numbers starting at 1 and less than 20. Now that's not including 20. So we're going 1 through 19. So if you would take a minute and just jot down what you think the answers are for these. The answer is on the next slide. So you can just pause here. If you're really anxious, then you can just go ahead and click to the next slide. But see if you understand what these terminologies and the symbols mean for this. And I'm just going to flip over. There's the answers there. So you can go back and forth here. I think these are also in your book, but just helps you know if you got it or not.